Hey there, welcome to today's lesson on section 5.2. Hope all of you are having a great weekend as you're watching this. And I'm recording this on Wednesday, so hopefully when you're watching this, you're enjoying watching Stanford beat USC, but we'll see if that happens. So 5.2 is about evaluating and graphing polynomial functions. Probably best if I define what a polynomial function is. So a polynomial function is basically a collection of terms that contain numbers, variables, and exponents. For example, 2x cubed plus x plus 1, that's a polynomial. You have three terms. The term with highest exponent is called the leading term. So the leading term here is that 2x cubed. The term with no variable is called the constant term. Constant means never changes. Variable means it could change, it could vary because you could plug in different values for x. But in this case, that's my constant term. More terminology. The degree of the function is the highest exponent. So for 2x cubed plus x plus 1, we see that the degree is going to be 3. So for our example, degree is 3. And lastly, the leading coefficient. So I probably should make these like bullet points. Leading coefficient, I think it's pretty obvious, is coefficient of the leading term, which for our example is going to be 3. Sorry, 2. For our example. The other thing that you need to know for polynomial functions for polynomial functions, exponents must be whole numbers. So it means no negative or fractional exponents. If you have that, you do not have a polynomial function. Also, no variable exponents as well. So I think that's all I wanted to say about that part. So let's now move on to the next part of the lecture, which is about synthetic substitution. So let's say, for example, we had the following. Remember this f of x thing? Let's set f of x equals 2x to the 4 minus 5x cubed minus 4x plus 8. And you're asked to find, say, f of 3. Actually, that's kind of cruel. Let's say f of 2. A little smaller. So you should remember how this works. So for direct substitution, all you would do is you'd say, okay, well, f of 2 equals 2 times 2 to the 4th power minus 5 times 2 squared minus 4 times 2 plus 8. Which would be 2 times 16 minus 5 times 4 minus 8 plus 8. Which would be 32 minus 20. And because the negative 8 plus 8 go away, so you just get 12. So it's not too bad. I mean, you have to be careful, obviously, that you're following all the order of operations, stuff like that. Now here's a really cool way. This is synthetic substitution. It's a new technique that I don't think many of you have seen. Here's how it works. You draw kind of like I don't know, like a half rectangle, if you want to call it that. You put your coefficients inside. So your coefficients obviously are 2, negative 5, negative 4, and 8. So 2, negative 5. Okay, I put a 0 in between negative 5 and negative 4. The reason why that's the case is because you have x4, you have x3, you don't have an x squared. So you got to put 0 in its place. Then you have an x, and then you have a constant term. So any exponents that get skipped over as you're counting down from the highest exponent, if it gets skipped over, you got to put a 0 in its place. And of course, we're plugging in 2. So that's our input, and these are our coefficients. Now here's how the process works. You bring down the 2, and you multiply those two numbers together, which is going to be 4. Then you want to add these two, which will be -1, and then you repeat the process. You multiply those two numbers together, which is -2, add, you get -2. Repeat. Multiply these two together, which is -4, add, and you get -8. And I think I made a mistake somewhere because it's not going to work out the way I want it to. Where did I go wrong? Five times 4 is 20. Oh, that is interesting. So you're probably wondering what went wrong with me when I did this problem. I forgot to cube the 2. I did a 2 squared. Okay, so that's -8. Good thing I'm doing synthetic substitution, so I was able to catch that mistake. So coming back over here now, we did -4 plus -4, which is -8. And then one more time, I'm going to multiply 2 to -8, which is -16. And that gets me -8. And so that last number there will be your result. Let's do another one, but I'll do a little bit more quickly. Let's say I do f of 3. So 2, -5, 0, -4, 8. So 2 times 3 is 6, add it, you get 1, 3 times 1 is 3, add it, you get 3, multiply it, 9, 5, 3 times 5 is 15, 8 plus 15, 23. And if you actually were to plug in 3 into doing direct substitution, you would get the same thing. So that right there is synthetic substitution. Okay, and then the last thing I want to discuss is something called end behavior. And here's how this works. So, we'll make a little table here. We're going to look at the degree. We're going to look at the leading coefficient. And we're going to look at the direction of the arrows. And when I say arrows, what I'm talking about are the ends of the graph. So for example, let's say I had a even degree and a positive leading coefficient. Both arrows are going to point up. For example, what if I have y equals x squared? Most of you should know that's a parabola that looks like this, right? Notice that both arrows point up. I like to think of it as, if you have an even degree, the arrows will be going the same direction. In positive, it's happy, so it's pointing up. What if I had even and negative? The both arrows point down. For example, if y equals -x squared, it would look like this, which makes sense. So even again, you expect the arrows to go in the same direction, but negative, so it's sad, so it's pointing down. if you have an odd degree and positive leading coefficient, the arrows will look like this. For example, if I have y equals x, I know y equals x looks like this. Notice that the degree is odd, because the exponent's not there, so it's 1. And notice how the arrows go in opposite directions. And if it's odd, and a negative leading coefficient, the arrows look like this. So when I think of odd, I think of like the arrows are at odds with each other, so they go away from each other. Positive meaning it's like going uphill. Negative means like it's going downhill. So in this case, that's why it looks like that. Up then down. So that covers end behavior, which we'll talk about in more detail when we actually do this stuff in class on Monday. Synthetic substitution. So I'll help you guys with that process when we do some examples of that on Monday. And then just some terminology with polynomial functions. So pretty comprehensive video. But again, we'll have a chance to practice all these concepts after the weekend. Alright, so enjoy the rest of the weekend, and I'll see you guys on Monday.